provided here, and this is the current graph. So what kind of supply is this? AC supply, right? Now I'm যদি এটার value গুলোকে square করি, I square. Remember root mean square? So root mean square was the first step. Square, right? Square করলে কি হবে? এই যে গ্রাফটা হয়ে যায়. Do you see the purple graph out there? That is the graph you'd get if you had what the values, squared the values, right? তারপরে যেটা করব আমরা স্কয়ার করার পরে স্কয়ারটাকে আমরা কি করি? মিন করব। সো এই স্কয়ারটাকে যদি মিন করা হয় তাহলে you get this value. তো এটা কিন্তু I think বুঝতে খুব easy. This is literally at the center there, right? So first we had our original current, ওইটাকে আমরা হচ্ছে স্কয়ার করছি and তারপর স্কয়ারটাকে আমরা হচ্ছে মিন করছি। But the current value is not actually the mean. It is the what of the mean root. So actually root kori 0.707 or 0.71. So that is the root mean square value. You see how the transition happened? So this is the true average that we have. Next হচ্ছে এটা তোমরা earlier দেখাইছিলাম নিচের গ্রাফটা একটু দেখো। So আমাদের sorry correct the cycle কমাই দেই। So do you see at the bottom on the left hand side you have the actual input, on the right hand side you have the output. Do you see that in the output there is like one cycle missing? So ওই cycleটা is the one that's rectified. This is known as a what rectifier? Halfway rectification. Okay, and এই মাত্র যেটা করলাম ওটা হচ্ছে এটা না এটা না Yeah, so look at this. Green হচ্ছে forward cycle, red হচ্ছে backward cycle. Green হচ্ছে forward cycle, red হচ্ছে backward cycle. And এখানে একটা জিনিস নোটিস করবে যেটার জন্য তোমাকে বলছি যে হচ্ছে জাংশনটা ইম্পর্টেন্ট. Do you see where did they place the resistor? কোথায়? Between the two junctions, inside or outside the rectifier? Outside, right? It's a thing they do. And sometimes students are put off by this. ওরা বুঝে না কি করতে হবে। এটা কি কমপ্লিকেটেড মনে হচ্ছে? ওরা কি করছে আমি একটু বলি। তোমরা কি বুঝছো ডায়াগ্রামটা কি হচ্ছে? আর নিচে দেখছো that the AC supply became a rectified supply on the right. So ওরা যেটা করে Cambridge's example হতে, they'll take this diagram, right, and they'll make an alternate version of this. And the alternate version is to confuse students. আর কোনো reason নাই, okay? So ওরা যেটা করবে is they'll not put this one here. And ওরা তোমাদেরকে বলবে যে হচ্ছে ডায়োড প্লেস করো সবকিছু করো, but you'll find, let me clean this thing there. Right, so you'll find that ওরা যেটা করে ওরা হচ্ছে তারটাকে এরকম করে একটা এরকম তার দেয় আর ধরো এখানে এনে এরকম একটা তার দেয় and বলবে যে রেজিস্টারটা এখানে রাখা. And then suddenly students will go like, wait a second, এটা কি এর বাইরে কেন, right? এটা কিছুই না কেন, because the current will come here, এখানে আসার পরে এদিকে যাবে নাকি রাইটে যাবে? লেফটে। তো এটা তো এটার ভিতর দিয়ে ব্যাক করে এখানে আসতে হবে। Isn't it the same thing? Now প্রবলেমটা কোথায় হয়? Some students who are seeing this for the first time, right? ওরা এটা দেখে কনফিউজ হয়ে যায়। They go like, না না না, কারেন্ট এদিকে যেতে পারবে না, তার কারেন্ট এদিকে চলে যাবে, right? কেন? Because they think that এটা তো একটা সার্কিট এরকমই তার হবে, right? But the problem is that's a Cambridge problem. Because internationally, if they do this, this is not how they draw it. Do you know what they draw here? Yes, এরকম করে draw করে. This is the actual way of showing that a wire is not a junction. But Cambridge doesn't do that. So যারা একদম first time দেখতেছে, they get confused. They feel like there is a possibility that this is like a junction as well. So junction এর জন্য definitely কি দেয় ওরা একটা dot. ওইটা ওরা আবার করে. So ওরা যেটা করে এটা না করে ওরা যেসব জায়গায় junction হয়, they put a dot there. So that implies that any place that doesn't have a dot is not a what? Junction, okay? Clear about that? So yeah, I'm going to start the rectification. So we're going to make it into a straight line here, okay? A straight line convert kora, there's a name for the process, it's called smoothing. Okay, এদিকে দেখো বেশি টাইম লাগবে না I think we can wrap it up fast I thought আরো বেশি টাইম লাগবে so we have this graph right now we have this circuit at the moment we will want to make our graph a what line straight line that's it that's the straightforward thing that we want and how can we achieve that so to achieve that there are certain ways out there we have to use capacitors and এটা ক্যাপাসিটর চ্যাপ্টারই শেখানো হতো আগে বাট এসি চ্যাপ্টারটা আসার পর থেকে এখন এটা এসি তে করাই আমি so it's a capacitor function so what do we do here so what we do is we place a capacitor and listen very carefully parallel to your component okay তোমার component যেটাকে তুমি হচ্ছে চাও যে এসি সাপ্লাই ডিসি হয়ে যাবে ওটা parallel you place a capacitor and turns out this can actually convert the supply into a flat line. How is that so? So to বুঝার চেষ্টা করি আমরা এই জায়গাটা একটু attention দিও একটু complicated like little bit not that much. So look at our graph here. This is the rectified AC supply that we have. এখন যেটা হচ্ছে that আমার কারেন্ট এদিকে যাচ্ছে কারেন্ট এখানে গেল কারেন্ট এদিকে আসলো এদিকে আসলো এদিকে আসলো এখানে আসার পরে it goes into my component and also it goes where into the capacitor. What happens when current goes to a capacitor? Yeah, it charges. Capacitor charge হচ্ছে. So I'm going to use a blue color here to show the capacitor charging graph. So capacitor টা এখানে charge হচ্ছে. And if you remember capacitor charging graph টা এরকম দেখতে ছিল। আর discharging graph টা হচ্ছে এই যে এরকম দেখতে থাকে, right? So the capacitor is getting charged here and also আমার component টা কি হচ্ছে? Voltage পাচ্ছে. So the black line here represents your watt, the line for your AC supply. The blue line represents the line for the capacitor being charged, and the green line are the line which এখানে একটু বেশি লাইন হয়ে যাবে the problem, but দেখে তোমাদেরকে direction. Use a shade here. Right, so the green line that you see here, a green line to right. The green line represents the component's voltage. So you can see the graph. Do you see the three colors? The black color at the black color the key represent for it, your supply. Okay, blue color the key represent for it, the current and voltage across your watt capacitor. Are green the key represent for it, the current or voltage across the component. শুরুতে they all are getting the same current. So supply দিচ্ছে এটা ও পাচ্ছে supply দিচ্ছে এটা capacitor চার্জটা বাড়তেছে এভাবে রেজিস্টার ভোল্টেজটা চার্জটা বাড়তেছে এভাবে ওকে আমি এটা ভোল্টেজ বানাই দিই তাহলে ইজিয়ার হবে ক্যাপাসিটর চার্জিং এর জন্য ভোল্টেজটা বোঝানো ইজি সো ভোল্টেজটা বাড়তেছে এভাবে সো রাইট নাও at this point what has happened my capacitor is fully charged right my component has a maximum voltage across it my supply has reached what value peak value but কি হবে next যেটা হবে my supply goes down right because my supply is an AC supply, but my capacitor won't go down. And the reason behind that is capacitors don't discharge instantly. Capacitors take what to discharge? Time. And the discharge of a capacitor looks like what? That graph, right? So the capacitor will start to discharge on its own way. And capacitor discharge এরকম করা start করবে, like it's a little slow. Remember the discharge of a capacitor কিরকম দেখতে হয়? So the capacitor is discharging this way, which means right now a part below your AC supply is going down, right? So our component across it, the AC supply is going down, but who's still there to provide the voltage? The capacitor. So there's a analogy out there. It's basically a support system. So তোমার যেটা হয়, this is the voltage of the resistor, right? And this is the AC supply. AC supply যখন fluctuate করে, voltage across the resistor fluctuate হওয়ার কথা. But আমরা কি করি আমরা এটাকে সাপোর্ট করার জন্য পাশে আরেকটা কি রাখি as a backup a capacitor so when my AC supply goes down who's there to support my component the capacitor হচ্ছে ব্যাকআপটা দেয় capacitor আস্তে আস্তে কমতেছে meanwhile AC supply কি forever চলে গেছে না তো isn't it going to come back again as it comes back again what does it do to the capacitor charge it back up আবার AC supplyটা নেমে যায় তখন আবার capacitorটা সাপোর্ট দেওয়া স্টার্ট করে so basically the capacitor acts as a backup for the times when the supply is not there. So এই সব জায়গাগুলো যদি নোটিস করো এই যে these places the supply is not there the supply is going down the component will use the voltage from whom rather the capacitor but then again what happens here the supply is back And as the supply comes back, it will take your capacitor where again? To the peak, because again it's getting charged. Again, the supply goes away. Who looks over as a substitute? Your capacitor, right? So এটা বারবার হতে থাকে, and now you start to notice আমাদের যে আউটপুটটা হবে, the output is not going to be the black line, it's actually going to be the blue line. So blue line এর গ্রাফটা যদি প্লট করি, মানে that's the resultant, right? So but green line, greenটা actually বাদ দিয়ে রাখি for the time being. So আমার হচ্ছে আউটপুটটা এরকম দেখতে হয়ে যাবে, because যখনই ক্যাপাসিটর চলে যাচ্ছে, যখনই আমার সাপ্লাই চলে যাচ্ছে, who is actually taking over? Capacitor. And as a consequence, you'll find that instead of this happening, it is actually like that. It's going down. Supply comes back and takes it back up again. It goes down. Supply comes back up and takes it again. It goes down, right? But does it look like a straight line though? I mean, would you consider this to be a straight flat line? No, right? So is there a way where we can make our capacitor discharge, right? A straight line or flatter? What was it? Yes, and what can you do to make that happen? Like make it discharge slowly? Tau equals to RC, right? So you can increase your R or you can increase the C. If I increase my capacitance, do you know what will happen? The discharge will look like this. R2 slow hobe, and eta R2 slow hobe. Is it not a bit more flatter than previously? Now, what if I make my capacitor even higher? Let's say I go full in, right? Wouldn't it be like really slow at the discharge? Let's say it's trying to discharge, but before it can do anything, what are you doing? You're coming back again, right? So I'm going to draw kori. Let's get rid of these. Frequency the করা যাবে, frequency তো আমাদের সেট থাকতে হবে 50 Hz থাকে যে, না ওটা করলেও হবে, but the thing is that our supply, we're talking practically, right? Practically the frequency is fixed everywhere, 50 Hz, right? What is the change for that? Yeah, if you increase the frequency, then it's like you're giving less time for it to go down and you're coming back more often. It's gonna work as well. So if you use, let's say 100,000 Hz somehow, right? You don't need a capacitor. It'll be like flat almost, because it can't even go down properly, right? So as you see here, if I use a very high capacitance, how does my graph start to look? Isn't this a little better than before? It's almost a straight line, but not a straight line. Then what if I take a capacitor that is so large, right? When it is so high that it barely gets chance to discharge? Wouldn't you end up with something that looks like that? And in that case, doesn't that look quite like a straight line? Now you might say, no, I don't buy it. It's not straight line, right? You're looking at one cycle out there. When you're working with your supply, right? In 1 second, how many times does it go up and down? 50 times, right? So I'm 50 times 1 second I'm 50 the cycle niyashi, and I place them like that. From this point of view, what does it look like? Straight line, right? Now you might say, no, I don't buy this either, right? It's fine. I have a solution for you. There's always somebody who goes like, no. So do you see that's a discharge of a capacitor? What's the capacitance value on the side? 0.01 into 10 to the power minus 8. Dekte parcho left. See what I do right now. I increase it, right? What did it become? Little flat, right? Let's go further. What did it become? More flat. And what I can do here is I can combine the resistance as well now, right? Because resistance will vary kora jay. And at the point I think you shouldn't argue. This almost looks like a what line? Straight line. Eta jodi use kori, what would it eventually become? Flat, right? But eta keu kore na. Eta oi ami jeta dekhaichi otuke actually is good enough for most people. Okay, so there you go. This is called the smoothing process. So smoothing korar jonno, the key part here is to ensure that your capacitance is large enough that the graph doesn't fluctuate much, right? Low capacitance use kore ki problem hobe je erokom hobe, মানে it falls very rapidly before it comes to the next cycle, right? And এগুলা সব হচ্ছে collective output is this one there. Do you see how it looks like? Okay, so that's the rectified version. The fluctuations that you see there, that's basically the capacitor trying to go down. Who takes over later on? So supply. So একটা জিনিস এখানে নোটিস করো, তোমার একটু বুঝতে ডিফিকাল্ট, বাট আই থিংক তোমরা বুঝবা। ক্যাপাসিটরটা দেখছো 102 মাইক্রোফ্যারাড লেখা, ওইটার থেকে চার্জটা কেমনে যাচ্ছে একটু চেক করো। ডু ইউ সি দ্যাট চার্জ বের হয় আবার ঢুকে, বের হয় আবার ঢুকে? বুঝছো হোয়াট আই এম টকিং অ্যাবাউট? এই যে জায়গাটা, যে দেখো দ্য ইয়েলো ডটস অন দ্য টপ, রাইট? একটু বের হয় আবার ঢুকে, বের হয় আবার ঢুকে। ক্যান ইউ এক্সপ্লেইন টু মি বের কখন হয়? No, the capacitor is parallel to my component, right? Do you see that the yellow dots on the top are moving out and then they go in again and then move out? Yes. So when it moves out, that's when the capacitor is supporting your component. But capacitor discharge হয়ে যাচ্ছে না? Later on, who comes and pushes the charges back in? Supply. তখন আবার fully charged হয়ে যায়, আবার discharge হয়, আবার fully charged হয়ে যাচ্ছে. And this, pull and push cycle ensures that the component on the right hand side, check করে দেখো, continuously একটা constant flow পাচ্ছে. That's how you ensure there's a constant flow up there. Here.
Sir,
Yeah.
isn't this inefficient? These capacitors have like,
Oh, right. In terms of energy, yes, it's by default you're losing some of it, but not a lot, because you're not fully charging it. You're not using all the charge out there. So that's if you fully charge it and fully discharge it, it'll be like 50%, like max, right? But you're not utilizing the entire process. It's just a small amount. So it's inefficient, but it's not that bad. Okay. Clear? Right. So that is smoothing. এটা হচ্ছে একটা নোট আছে, এটা আমি আপলোড করব, একটু বুঝাই নিই তোমাদেরকে। সো ফার্স্ট অফ অল আমরা হচ্ছে এটা করি, তো তোমাদের এক্সামে কি কোশ্চেন আসতে পারে এখান থেকে? they'll ask you the whole thing step by step, right? Or they'll ask you to do some math, কি ম্যাথ আসবে ওটা বুঝাচ্ছি। But the first thing you need to do is to ensure your AC supply becomes like this. কি ইউজ করতে হবে? A bridge rectifier. Once you have used the bridge rectifier, you need to apply a watt across your component, a capacitor, and then this happens. A capacitor is added parallel to the component. When the supply voltage increases, the capacitor gets charged. When the supply voltage decreases, the capacitor takes over supply voltage. It becomes the main supply. If a large capacitor is used, the discharge is slow and the voltage remains constant. And if you see here, supply যখন বাড়ে, capacitor বাড়ে, supply যখন কমে, capacitor কমে না। কেন? capacitance অনেক high, তার জন্য discharge হচ্ছে না। That's why you'll find the capacitor value remains constant, the voltage, তার জন্য component across the voltage সবসময় কি থাকে? Low থাকে। It's basically every time your capacitor goes, pushes it back up. It goes down, pushes it back up. That's what's happening. Now, if it goes down very slowly, it doesn't need to push back up much, right? It almost stays flat. So the voltage is just a support act here from the supply, trying to keep it up all the time. Capacitor does main pulling here, pull it and power there. Okay. Right. So that is smoothing. With that, we are done with the topic. I'm quite fascinated quantum physics. But এখানে কোনো question থাকলে আমাকে বলতে পারো। I'll take everything of this topic together and upload them today. So তোমাদের যা missing notes আছে একটু copy করে নিও। Clear? All right. So তাহলে হচ্ছে Saturday we'll start quantum physics.
Recording stopped.